Okay, we're going to start this video on test 2. So the test came from a test bank. So some of these questions might be the same as yours, others might just be similar. So let's look at my question 1. And this is the graph that's given, and they want you to identify the graph of g of x plus 3. So when your plus 3 is just tacked on at the end, then we have added 3 to the equation, and when you add 3, you shift 3 units up. So this point is going to be shifted 3 units up. 1, 2, 3. So it's still going to have the same x coordinate, but its y coordinate is going to be 3 units up from 2, so its y coordinate is going to be 5. And then I'll have the same shape. So what I've drawn there in red is what we want to see as our answer. So I'm looking for the reference point there that's going to be -3, 5. And if we scroll down, there it is. So I'm going to choose that one. All right, so let's go on to the next. All right, now in this example, we are not, we do not have a vertical shift by 3. Because we have not added 3 to the equation, we have replaced g of x with g of x plus 3. So x inside the parentheses has been replaced with x plus 3. And in that case, we have a left shift. So there was that chart, and you'll have to know that chart for the final. So also the final is closed book, which is why you have to take a final being monitored. Because it's closed book. So you'll have to know the chart. If you replace x in the parentheses by x plus 3, that's going left 3 units. So this reference point, I'll move it left 3 units. So 1, 2, 3. And so my new reference point, the x coordinate will be, I'll subtract 3 from that, so it'll be -6, and the y coordinate doesn't change because I'm just doing a left shift. So I'm looking for the selection that has as its reference point -6, 2. And there it is. Okay, so let me clear out that. All right, with this next one. All right, now what's going on here? This is our original function, and then this is the one that we have. Now, I'm thinking that what's happened here is, notice that this goes down like that, and then this one is going up like that. I think what's happening here is that we're taking the original and we're reflecting it or flipping it in the x-axis. So let's just, and I'm going to do this freehand. So if this part, if the x-axis is a mirror or a pond, the reflection of this one is going to look something like that. If the x-axis is a pond, this part is underneath, and so its reflection is going to look something like that. If the x-axis is a mirror or a pond, this part is above, and its reflection is going to look something like that. This part is below the line, the x-axis, so its reflection is going to be above. And then this part, its reflection would look like that. And so what I've drawn in red here is what we have here. So if you start with f of x and you reflect in x, then from the chart, that's going to give you negative f of x. So again, it comes from knowing the chart. So this is the one we want. That's a reflection in x. This one here is a reflection in y, again from the chart. And this one is both. You reflect in X and then you reflect in Y, and the order doesn't matter. So we need an X reflection, and so that's what we're going to have here. Okay, so let me get rid of that. So again, this came from a test bank, and this question was an X reflection. One of the test bank questions was a Y reflection. Okay, so make sure you know the difference. And if you got a Y reflection and you don't understand why, then email me and we'll work it out. Okay, so let's see what's going on here. Okay, so the old one's going to be h of x, and the new one is going to be h evaluated at 3x. So again, from the chart, if I have a point on the original h and I want a point on h of 3x, I'm going to replace the x with 3x, then my new point is going to have the same y coordinate, but the x coordinate is going to change. And in this case, again, it's from the chart. My new x coordinate is going to be 1 over 3 times x. Okay, so I can see some points here. I have -3 comma -3, and I have 3 comma 3. And let's see where they're going to go to. So I'm going to take 1/3 and multiply it by the first, by the x coordinate, and 1/3 multiplied by -3 is going to be -1. But the y coordinate's unchanged. And here, if I take the first coordinate and multiply it by 1/3, I'm going to get +1. So these are the two reference points I'm going to be looking for. And with this one, it looks like I've got that first selection is the correct one. So I've got -1 comma -3, and then I've got 1 comma 3. So that first one is the one I'm going to pick. Okay, let's go on to the next one. All right. So we're starting with f of x. And we want to finish up with f of -x plus 3. So there's a couple of ways I can do that. I'm going to have to do this in 2 steps. And then let me get another color. Okay, now I'm doing the reflection first. I'm not doing the vertical one till the end. There are other ways you could have done the vertical and then reflect, but this is what I'm doing. Okay, so when I take the blue one, and to get to f of -x, that will take the blue one and reflect it in the y-axis. Okay, so here I'm going to take this blue one and reflect it in the y-axis. So this bit reflected is going to give me that over here. This bit reflected is going to give me that over there. And this part reflected in the y-axis is going to give me that over there. So what I've drawn in red is f evaluated at -x. So then I'm going to take the red one and I'm going to move it up 3 to get the green one. All right, so I'm going to take this one and I'm going to move it up 3. Now notice I don't have a grid system, so I just want to make sure I get it in the picture. Okay, so it should be looking something like that. All right, so when I'm looking at these selections, I want them to match up with the green. Okay, so there's no way that first one matches up with what I had there in green. There's no way. All right, let me make sure I haven't skipped any. All right, there's no way the first or the second one matches up what I had in green, or the third, or the fourth, or the fifth. That last one is the only one it could possibly be that matches up with the green. Okay, so I'm going to put it there. So let me put that. Okay, let's go on to question 6. All right. Now we want f of x plus 2 minus 2. Okay, so I'm going to start with the red one because the red is the original. And I want to get to f of x plus 2 minus 2. All right, now again, I'm going to do the horizontal shift first. You didn't have to. You could have done the vertical shift first. But it's going to have to be done in 2 steps. Okay, so I'm starting with the red one. And how do I get this blue one? Well, x is being replaced inside the parentheses by x plus 2. And so by the chart, that's 2 to the left. So I'm just going to do this freehand, but these 3 reference points are all going to be shifted 2 to the left. And then these 2 humps will be shifted 2 to the left. And then I'm just going to freehand draw them in there. Okay. All right, so that's the picture of the blue one. Then I'm going to take the blue one, and to get the green one, which is what we want, I'm going to take the blue one and shift it down 2 units. So take the blue one and shift it down. So all of these reference points, I have these 5 reference points. I'm going to start with them getting shifted 2 down. And so that's going to look like. All right, so what I want is the one in green. My answer will be the one that matches the one in green. Okay, so let's have a look-see. All right, that doesn't match what I drew in green. That does not match what I drew in green. That does not match what I drew in green. That is matching what I drew in green. That does not match. All right, obviously couldn't be any of those. Okay, so now it looks like we're out of the transformations, and now we're looking at identity, contradiction, or conditional. Now let me get rid of this and get to black. And let me do that. Okay, so first of all, if it's conditional, you have a specific answer, one unique answer. If it's an identity, the x's will eliminate each other and you'll have a true statement. If you have a contradiction, you have a false statement. So let's solve this thing for x. Well, first of all, I can combine these. So I haven't done anything to the left-hand side, but the right-hand side, 6 minus 3 is 3. And now if I subtract x from both sides, I meant to do that in red. If I subtract x from both sides, then the x's cancel, and what I'm going to be left with is 2 equals 3. Now that is not true. That's a false statement, and when you have a false statement, you have a contradiction. Now if when I had canceled, I got 2 equals 2, and my x's had canceled, that would have been a true statement, and that would have been an identity. If I had gotten an actual unique value for x, if my x's hadn't canceled and I got x equals 5 or something like that, that would have been a conditional. But in this case, I have a false statement, so it is a contradiction. Okay. Let's move on to the next one. Okay. All right, so identify the type equation. Again, I need to solve for x. So I'm not changing the left-hand side, not yet, but on the right-hand side, I have 5 minus 3, which is equal to 2. Okay. Now, if I want to solve for x, how about we add x to both sides? Because I want to get rid of this one. So when I do that, this will cancel. And I'm going to be left with x plus x is 2x. And now let's subtract 2 from both sides. So these will now cancel, and I'm going to have 2x is equal to 0. And then divide both sides by 2. And I'm left with x is equal to 0. Now, I have a unique value for x. I have solved for x. And when you have a unique value for x, you have a conditional equation. All right, get rid of that. Let's go on to the next bit. All right, find the slope of the line containing the 2 points. All right, this is, I believe, Lab 9, which was if you have 2 points, you can always find the slope. So the slope is going to be the change in y over the change in x. And so we're going to have okay, sorry, I just couldn't. All right, I wasn't able to get these to change, so I was just wondering what was going on. So sorry about that. Let me put this back up. So the change in y over the change in x. And so I'm just going to take them as they come. So change in y, so this y coordinate minus this y coordinate all over the change in x. So this x coordinate minus this x coordinate. So I'm going to get negative 6 in the numerator, and I'm going to get negative 8 plus 7 in the denominator. So I'm going to have negative 6 over negative 1. The negative signs cancel, and 6 over 1 is just 6. So I'm looking for positive 6, which is what we have here. Okay, and you could have graphed it like freehand. So where is negative 7 comma 1? All right, that point is about there. And negative 8 comma negative 5 is about there. Okay. And so if I put those together, the line going through them, I can see it has positive slope. How can you tell that? Well, from the instruction notes, if you're moving left to right and you're going uphill, you have positive slope. So I could have ruled these out, and so you could have done it that way. You could have ruled half of them out, because I think the biggest mistake students make here is they get the negative signs. They don't see that two negative signs cancel. Okay, so anyway, let's keep going. All right, find the slope of the line. You can find the slope if you know any 2 points. And this was also a web work question where they gave you the graph and you were free to choose the point. You're still free to choose the points, but they've suggested a couple of points here because those are the easy ones to see. So you can see from this graph, you've got the point -5, 0. That's this point here. And from this graph, that point is 0, -5. Now, again, as I move from left to right, I'm going downhill. So the slope is going to be negative. So I can immediately rule those out. Okay. So the slope is going to be the change in y over the change in x. And so again, it doesn't matter what order you take them from. So once you write them down, this is the first, that's the second. So it's going to be this y coordinate minus that y coordinate all over this x coordinate minus this x coordinate. So I'm going to have in the numerator -5. And I'm going to have in the denominator 0 minus -5, which is 0 plus 5, which is 5. And then 5 divided by 5 reduces to 1, so I'm going to have -1. So my answer is going to be -1. Okay. Okay. All right, now find the equation of the line in the slope-intercept form. So again, first thing we do is find the slope. Again, we are shown 2 points. Now, if you can find other points that are easy to see, that's fine. But the ones that they have given to us, this one here, its x coordinate is -5. And its y coordinate is -3. And this one here, its x coordinate is -4. And its y coordinate is 2. And I can see that this has positive slope, the line. As I move from left to right, I'm going uphill. So that actually, when it's in this form, then it doesn't make any difference. Okay, so let's get the slope. Now, my 2 points, and it doesn't matter the order that I list them in as long as I calculate the slope correctly. So it's going to be the change in y over the change in x. So I'm going to have this y coordinate minus this y coordinate, all divided by this y coordinate minus, this x coordinate minus this x coordinate. All right, we have to be really careful with the negative signs here. So in the numerator, I'm going to have 2 minus -3, which is 2 plus 3, which is 5. And in the denominator, I'm going to have -4 plus 5, which is going to be +1. So the slope is equal to 5. Now, because of the way this is written, I can immediately recognize which ones have the slope of 5. This one does not have slope of 5. This one has slope of 1/5. So I can rule that one out. Okay. Now, if I have a point and the slope, I can get the equation of the line. So I'm going to use the slope-intercept form, and I have 2 points, and I am free to choose whichever one I want. I'm going to choose this one because it doesn't have as many negative signs. That one has 2 negative signs. So if I use the slope-intercept form or point-slope form, there are different forms you can use. You just have to match it up with the form they have in the answers. I know that y minus the y-coordinate of my given point is equal to the slope times x minus the x-coordinate of my given point. So this is going to be x1, y1. So this is one way to do it. So I'm going to have y minus y1, which is 2, is equal to the slope, which is 5, times x minus x1, and x1 is going to be negative 4. So I'm going to have 5 times x plus 4. So now I'm going to distribute the 5. And now to get this to match these forms, they have y by itself on the left-hand side. I'm going to add 2 to both sides. And then that's going to give me y, because these will cancel, is equal to 5x plus 22. So that's the one I want. That's going to be the one that I want there. Okay, so that's the one I want. Okay. All right. So once again, it looks like we have the same type of question. So this is the luck of the test bank. Okay, so what are my 2 points? My 2 points are going to be -5, -3, and -4, 2. Okay, it looks like this test bank has repeated the question, and that should not be possible. So I'll have to go and look at the test banks. It looks like the test bank repeated the question. So again, it should be 5x plus 22. Okay. So nothing I can do about it for this test. All right, find an equation line with the given properties. A horizontal line containing the point. Okay, so for this course, you absolutely must know the difference between a horizontal line and a vertical line. And so question 13 and 14 deal with that. A horizontal line, you must know, has equation y equals a number. A vertical line has as its equation x equals a number. And you cannot get those two things confused. If you get them confused with each other, you're going to lose all your points. So here we go. We have a horizontal line. Now, this could have said so in Lab 11 instructions, example 1, example 4. We could have gotten something like parallel to the x-axis. That's a horizontal line. So a horizontal line, so y is equal to a number containing this point. Well, what's the y-coordinate of that point? It's y equals -4. And that's your answer. And if you know the difference between a horizontal line and a vertical line, then you will get, that's an easy question. Okay, let me just, okay, so that's going to be this one. All right, now with this next part, we're on a vertical line. So a vertical line has as its equation x equals a number. You must know that. So instead of vertical line, you could have been given, find an equation for a line that is perpendicular to the x-axis. That's a vertical line. Or parallel to the y-axis. That's a vertical line. But find an equation for a vertical line, so x is equal to a number containing this point. Well, there's your x coordinate. So we need x is equal to -6. All right, so the concept of knowing the difference between a horizontal line and a vertical line, once you know that, these are simple questions. When you get them mixed up, you're throwing away easy points. Okay. All right, so let's continue. All right, now, if you put these in your graphing calculator and look at them, then two parallel lines look like this. Perpendicular lines have a right angle between them. Okay, so look something like that. And of course, lines that are neither do have intersection, but they don't intersect at right angles. Now, that's fine. That's fine, as long as you put these in your calculator correctly. If you don't put them into your calculator correctly, you're going to get the wrong lines. Now, from the Lab 12, we have that parallel lines have the same slope. And we have the perpendicular lines have slopes that are vertical flips of each other, negative flips of each other. So their product is -1. So if one slope is 3, the other is -1/3. If one slope is 1/5, the other slope is -5, okay, for perpendicular lines. And if it's not either of these two, then they're not parallel or perpendicular. So what's the slope of this? Well, the slope is not 3. It has to be in the form where y is by itself on the left-hand side. And if you're going to put this in your graphing calculator, you're going to have to write it to where y is by itself on the left-hand side. So you're going to have to do that anyways. So let's subtract 3x from both sides. And then let's divide everything by -4. And I'm going to be left with y is equal to +3/4 times x, and then plus 10/4. I don't even have to reduce that in this case because I can see that the slope of the first line is -3/4. Now let's look at the second line. So let's subtract 8x from both sides. And then let's divide everything by +6. And so I'm going to have y is equal to -8/6, which will reduce to -4/3. Oh, sorry, my bad. These negative signs cancel each other, so I'm going to have a +4/3 there. All right, sorry about that. They were different colors is what fooled me. So that's a +3/4. So that's going to be a +3/4. So here my slope is going to be -8/6, but that reduces to -4/3. And again, I don't need to reduce that because all I want is the slope. So my slope is going to be -4/3. So the slope of my second line is -4/3. Now, these two are negative flips of each other. If I take this one and flip it, I get 4/3, then negate it, I get -4/3. If I take this one and flip it, I get -3/4, then negate it, I get +3/4. So they're perpendicular. I could have also put them in my calculator and I could have seen that they were perpendicular. if I'm going to put them in my calculator, I need to have it written with y by itself on the left-hand side. So this first one would be y is equal to 3/4 x, positive 3/4 x, plus 10/4. I don't need to reduce it. My calculator will do that. And then the second one is negative 4/3 x minus 14/6. I don't need to reduce it. And then if I look at the graph of that, those two lines might not look perpendicular because it's in a standard viewing window. So the standard viewing window is Z6. If you look at it in a square window, then it should look nicer. In a standard window, it's not completely square, so your eyes might fool you into thinking that they're not perpendicular, but they are. It's better if you know the theory than to put so much faith in a graphing calculator and then have it fool you. So these are two lines are perpendicular. Now, if they had had the same slope, because this comes from a test bank, your question might have been two lines that were parallel. They would have had the same slope. And neither, then they wouldn't have had the same, and they would not have been negative flips of each other. Okay. All right, so this is another one. So for my test bank, this question, again, I'm going to need to look at the slopes. So I'm going to subtract 3x from both sides. Then divide everything by -6. And so I'm going to have -3 divided by -6 is positive 1/2. And that's those negative signs are going to cancel. So my first line has slope positive 1/2. For my second line, I'm going to subtract 18x from both sides. Then I'm going to divide everything by positive 9. So I'm going to have y is equal to -2x and minus 16. I don't need to simplify that because I just need to get the slope. And the slope here is -2. Now 1/2 and -2 are negative flips of each other. If I take 1/2 and flip it, I get 2 over 1, which is 2, and then negate it, I get -2. So once again, these are perpendicular. And again, I only got two examples, two questions that were perpendicular because that was the luck of the draw with the test bank. So ideally, it would have been great if everyone could have had one parallel question and one perpendicular question, or have it to where they're not the same. So one is neither and the others say parallel, but that's just the luck of the test draw. So just because we had two perpendicular ones does not mean that you shouldn't know how to do parallel or neither. Okay, now find an equation for the line with the given properties. Okay, let's start with this. Parallel to this line. Now, what do we know about parallel lines? They have the same slope. What is the slope of this line? Well, I do have y is equal y by itself on the left-hand side, so all I have to do is look at the number multiplied by x when it's in this form, and so this line has slope equal to -3. And parallel lines have the same slope. So this is what we want for the slope of the line that we're looking for. So we want the slope to be equal to -3, and it contains this point. Okay, so I'm going to call this x1, y1. And so now I can use the point slope form, which is y minus y1 is equal to, so this is a formula. I think all these formulas were in Lab 11 instructions, is equal to the slope times x minus x1. Okay, and then I'm going to fill in the bits. So I'm going to have y minus 3 is equal to the slope times x minus 5. And now I just need to put it into the form where y is by itself on the left-hand side. Oh, and the line I want has slope -3, and when it's in this form, well, I can't eliminate any of those. Okay, so let's just multiply this out. I'm going to have minus 3x and then plus 15. Okay, so I can rule that one out. And to match up with the rest of these, I just need to get y by itself on the left-hand side, so add 3 to both sides. So those go away, and I'm going to have y is equal to negative 3x and then plus 18, which is going to match up with that one. Okay, we're getting near the end. All right, so let me get rid of this. Now, find the equation of lines satisfying the conditions. All right, so it contains this point, and it's parallel to this line. So the first thing you have to do is get the slope. The slope is not -7. It's only the number multiplied by x when you have it rewritten in the form y by itself on the left-hand side. So the first thing we have to do is get the slope of that line. So I'm going to add 7x to both sides. And then I'm going to get y by itself, so I'm going to divide everything by 5. Now, when it's in this form, I can see the slope is 7/5. So I want a line with slope 7/5 and containing the point -6, 5. So if I call this x1, y1, I'm going to have y minus y1 is equal to the slope times x minus x1. Y minus 5 is equal to the slope, 7/5. Actually, I can stop there, can't I? This one has 7/5. That one does not have slope 7/5. That has slope 5/7. That has slope -5/7. That has slopes -7/5. So just from the slope, I can get this. But let's take it all the way. Let's just confirm that this is true. So m times x minus x1 so that's going to be x plus 6. So I'm going to have 7/5 x, and 7 times 6 is 42/5. Then to get y by itself, I'm going to need to add 5 to both sides. Now I can add those together with my calculator and it will give me a fraction, or I can rewrite 5 as 25/5. This is how you did it in the olden days before graphing calculators. And these will be, in the top I'm going to have 42 plus 25, which is going to be 67. Okay, and that does match with that one there. Or you could have done that in your graphing calculator. It doesn't matter. But as I said, you did not have to do all of that. Once you got the slope, then you could, from looking at it and process of elimination, gotten the answer. Okay, so we're quickly getting to the end. All right. Now, first thing we need to do is find the slope of this line. Luckily, that's in a form where we can instantly see the slope. The slope of this line is -2, because if y is by itself on the left-hand side, then the slope is the number multiplied by x. Now, what we want is the line perpendicular to that line. And perpendicular lines have slopes that are negative flips of each other. So if I take the flip of -2, I'm going to get -1/2 and then negate it, and I'm going to get +1/2. So this is what we want. I want the slope of +1/2. And now this has slope 2, can't be that one. This has slope +1/2. This has slope -1/2, can't be that one. This has slope -2, can't be that one. So I need go no further. By process of elimination alone, I get that one. So you don't have to do the work I'm showing you, but I'm just going to take it to the full. So if it had been parallel, I would have wanted the one with slope -2. It would have been like the last problem. But I'm going to take it to its full conclusion. Here's our point. So I'm going to call this x1, y1. And again, I'm going to use this form to get my equation, but I don't have to. Just from elimination, I get that one. So I'm going to have y minus -1 is equal to the slope, which is 1/2, times x minus x1, x minus x1, which is -3. Again, I don't have to do this. I've already got the answer, but I'm just going to, and that's going to be +3. So I'm going to have 1/2 x, and I'm going to have +3/2. And then to get y by itself, I need to subtract 1 from both sides. And 3/2 minus 1 is the same as 3/2 minus 2/2, which is 1/2. Or you can put that in your calculator and then do math, enter. All right, and so that confirms what we have here. So again, numbers 18 and 19, you only had to get the slope and then know that parallel lines have the same slope and know that perpendicular lines have slopes that are negative flips. You did not have to take it to its full conclusion, because those ones could have been done by elimination, just process of elimination once you had the slope. Okay, and now you have 2 points. If you have 2 points, you can get the slope. So what's the slope going to be? It's going to be the change in y over the change in x. So this y coordinate minus this y coordinate, all over this x coordinate minus that x coordinate. That's going to be 3 plus 7 over -4 minus 5. That's going to be +10 over -9. So my slope is going to be -10/9. Now, all I need is the slope and 1 point. It does not matter which point I choose. I usually choose the one that has the least number of negative signs. Since they both have the same number, just have one negative sign, I'll just choose the first one. But if I'd chosen this one, I would get the same answer if I do the same process. So this is going to be what I call x1, y1. And I can use the form y minus y1 is equal to the slope times x minus x1. So y minus -7 is equal to the slope, which is -10/9, times x minus x1. Okay, so I get y plus 7 is equal to -10/9 x. Then negative times negative is a positive, and so plus 50/9. Okay. and let's subtract 7 from both sides. And so I need to rewrite 7 to where it has 9 in the bottom. So 7 over 1, and then multiply both of those by 9, and I'm going to get 63/9. So let me take it back up here. I'm going to have y equals negative 10/9 x, and 50/9 minus 63/9 is going to be negative 13/9. Now, this is a correct answer, but when you look at the selections, it's not in that form. So if it's in standard form or general form, you have to have it written like this. And A, B, and C have to be whole numbers, integers. And then the A has to be a positive number. So first of all, let's get rid of the fraction. How do you get rid of the fraction? Multiply everything by 9. Everything by 9. So I'm going to have 9y is equal to negative 10x minus 13. Add 10x to both sides. And I'm going to have 10x plus 9y is equal to negative 13. And that's in the form I need. These numbers are integers, they're whole numbers, and the leading term is positive. So that's what I'm looking for. And that matches that one there. So I'm going to have, whoop, here. That's going to give me that one there. Okay. All right. So you can see my score is 100, so just make sure I got everything right. The only issue I see is that in my test bank, I did get a question repeated. So question 11 and question 12 in my test bank were repeated. So that might have happened to you, that might not have happened to you. It's a textbook test bank. So I'm probably going to have to go in there and see if there is a duplicate, if I can delete one of them. Unfortunately, a lot of times when test banks come from a textbook, they're fixed and I can't go in and change them. But I'll see what I can do about it. But that's about the only issue I had with this. Now, so what you need to do is to go back through your test, and once the answers are visible, which they should be by the time you watch this video, if you didn't get the exact same question that I got, if you got one that was similar, you need to go back through and make sure that you can get to the correct answer for your test. And if you cannot, then email me so we can get it sorted out. All of the test questions that I choose are questions from previous final exams. So there is nothing more important than going back through your test and figuring out where you went wrong. Okay, there's nothing more important than that, because especially once students see the difference between a vertical and a horizontal line, that is the most common mistake at this point in the course when you've taken your first test, is that students confuse the equations for vertical and horizontal lines. And just that one thing, if you'd gotten that straight, you probably would have gotten 2, possibly 3 questions correct if you got them wrong, and that would have made a big difference in your score. So those kind of things you need to know for the final, and if you don't make those mistakes again in the final, you're going to be just fine. Okay, so I've gone on long enough. I'm going to stop this video. That concludes test 2 solutions.